This is Algebra 1, Term 4, Lesson 11, Completing the Square. We'll begin with the Desmos activity, and then we'll use a GeoGebra model, and we'll finish up with a card matching task. So let's begin with Desmos. This is the Desmos classroom activity, Completing the Square. This will take the bulk of your time. We are covering a variety of standards, and there are 17 screens. In the first screen, they will move these tiles into these spaces, and then they will put an expression here for the polynomial that's being represented by these tiles. In this one, they're going to type a number to fill the bottom right corner, and when they do, this tile will appear and they will place it to fill the corner. So what's happening here is they are going to learn that a perfect square trinomial is our goal here, and so this will show them the full trinomial, including the corner, when they've selected the number for the corner. So in this one, they're going to place these tiles in this space, and then obviously one of these tiles will not fit, and then they will choose that answer, and when they do, it will give them another question to answer. And then they show them a model. Now, as you're going through this activity, it's super important that you pace your students to advance one screen at a time. I would say working together as a whole class or in teams is wise, answering questions. When you get to screen number 6, the students will be creating their very own equation. This is technically something they could put into a portfolio because they're creating their own value of b and c to make a trinomial. They may have figured out that it's kind of nicer when they choose a b value that is even versus a b value that is odd, but they are welcome to do that. They can also use negatives. Now, unfortunately, these models all produce green for positive and negative on these X tiles, which is unfortunate because we use red for negative normally. In this case, it's okay. We will have red tiles from hereafter, but for this assignment, just know all the tiles are going to be the same color regardless. On this screen, it will display a model for the tiles that they created on the previous screen when they typed in their B and their C. This is vertex form or completed square form. And then they're going to go back and review solving using inverse operations. So we're going to solve by isolating the variable. They can do math.new, and that is a suggestion in your teacher moves. On this one, they have the equation given in vertex form. Solve this to find the zeros and input your work and solutions in the box below. When I did this activity, I had students using mini whiteboards, and then they would click here and they would upload a picture of their work into that box. You could also have them type it out or write it out on paper. For this one, they're going to put these in order from standard form, which is this form here, to the final solution. So you're actually going through it, the whole process from start to finish. They're writing the equation in vertex form and then using vertex form and solving using inverse operations. For this one, we have another equation. It says here to first write it in vertex form and then solve with inverse operations, input your work and your final solutions. Please be sure to review the teacher moves and sample responses, and it does pretty much go through the entire process to show you what the kids need to be doing. And if you're not seeing that, then you maybe intervene. Okay, instead of using the tile model, we also have the option of using a box. One thing I've learned about quadratics is it takes time for kids to learn this, and realistically, many kids learn it well in Algebra 1. I'd say most kids that learn this well learn it after Algebra 1 and Algebra 2 and beyond. But what I've discovered is the more I give them, more different tools I can give them to work with, there's more opportunity for them to make sense of it. So we're going to use both the tiles and the box, and of course we're going to also use the graph. One suggestion I put in pretty much all the teacher moves is to have them be checking as they go using their calculator. They can look for the zeros of the graph, and that's going to help them, or the vertex of the graph, and that's going to help them make sense of this model as well. So have them looking at that. It's okay. Some teachers think it's not good if they can see the graph, but I think that's just the opposite. They need to make that connection to really make sense of all the models that we use for quadratics. And then there's going to be 2 more questions at the end where they go from start to finish. Here's an equation in standard form. Take that equation and write it in vertex form using this box, and then set that equal to 0 and solve to find the zeros. 1 more slide doing the same thing. If you are seeing they're not making good progress, I'm going to show you something you might want to be doing. If you type math.new into any browser, it will take you to Graspable Math. And so on any of these equations, if these kids are struggling to get through a problem, they're not making sense of it, they don't remember inverse operations, then they should be coming over here to math.new. So I'm just going to enter some random equation in here and go through the process with you. So the goal is to isolate the binomial squared, which I've already done. But of course they could do that in here too. And then you're going to take the square root of both sides. And then you're going to get the plus minus. You can talk about that again. And then they need to add 3 to both sides. Now this is technically your answer. That's almost impossible to type in Desmos though, because there is no plus minus. One option is to go out and paste the symbol for plus minus from another site, which I do have kids try to do that because they want to make it look like this. You can also have them do it in here and take a picture of it and insert that picture. But alternatively, they could just separate these and write these answers as 2 separate solutions. I do want to show you also that they can use a graph to check. So let's take a look at Desmos. So if I were to type my function into the calculator, of course it's going to cross the x-axis, and the answers are not very pretty, and that's because we have irrational solutions. One solution was 3 plus the square root of 11, and the other was 3 minus the square root of 11. So what they will do is they will type these in. 3 plus the square root is SQRT, and you'll notice that it produced a vertical line that went through that x-intercept, so that's telling you that was a solution. And then x equals 3 minus the square root of 11 is going to go through the other x-intercept. The next thing we'll do is go back to our slides and do a quick GeoGebra task where they're going to create a model. On the completing the square model, the first thing they're going to do is put in their coefficient, which is automatically going to be 16 when they first go in here. So they can change this to something besides 16. And then they're going to create the model to go with it. So they do that by sliding these all the way over. Now once they do that, it's going to ask them a question. How many ones do I need to complete the square? And when they do, it's going to, if you click here, it'll show the number and they can count them up. But hopefully they don't need to count them up. And then they're going to take a picture, put it on the slide, and just answer the question. So they will type here and answer the question. They'll create it again, this time make that middle term negative 12x. Doing the same thing, how many tiles did they need? This is very quick. It's just change that number, take a screenshot of the tile model, and put the number here. All right, there's the third one, and then they have a 4th one. So they have a total of 4 of these slides. The next thing they're going to do is solve by completing the square. Here they're just working on a whiteboard. I'm getting them started by showing them what goes on the box, and they're just going to drag these in here. So they grab them and just pull them into place. And then they'll work out this part over here on a whiteboard and take a picture and insert it. They'll do the same thing here. They'll make a box and they'll insert this. When they get to the next screen, they don't have a box. They're going to make their own box. So they'll put the box and everything on the slide and just take a picture of the entire thing and solve the equation by completing the square. And here. And then finally, there's a card sorting activity. They're given a graph and they're going to look for 3 equations and 2 box models to fit. And let me show you what that looks like. You'll just give them this one sheet. So each student, if you want them to do it independently, or you could do it in pairs, and that's kind of how I recommend it. So they would take one of these sheets, cut it out, and then find all the ones, there should be 5, that go with each of these slides. And they will take a picture of all the cards that fit this graph. Then they will take a picture of all the ones that fit this graph. And so they'll have a total of 4 graphs, and each graph should be paired with 5 cards. Of course, each card is used only once. So that concludes our completing the square activity. This is like heavy duty skill practice, so we didn't have any applications today. That will change next time. We'll look at more applications for quadratic functions. Y'all have a great day.